Welcome to WE Math class. Today we will continue Fourier series expansion of a function f of x. In this first video, we will know Euler's formula for Fourier series of a function f of x. What is this? Uh, Let f of x be a periodic function with period 2 pi. Suppose f of x can be expressed as a trigonometric series in the interval c less than x less than c plus 2 pi as follows: f of x is equal to a0 by 2 plus summation n equal to 1 to infinity a n cos of nx dx nx plus summation n equal to 1 to infinity bn sin of nx. Then the coefficient a0 an bn is given by a0 equal to 1 by pi integration c to c plus 2 pi, this limit c to c plus 2 pi f of x dx, and an is 1 by pi integration c to c plus 2 pi fx cos of nx dx, and bn, this is equal to 1 by pi integration c to c plus 2 pi f of x sin of nx dx. In both the cases n equal to 1 2 3 dot dot, and for particular case we done if c is equal to minus pi. C is equal to minus pi, the interval become, if we put c equal to minus pi, then minus pi less than x less than 2 pi minus pi equal to pi, this limit. And here we get same form of fx, but the limit will be changed. F of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin of nx, and a0, this is equal to 1 by pi, if we put c equal to minus pi to pi, minus pi to pi fx dx, and also an is changed, an is equal to 1 by pi integration minus pi to pi f of x cos of nx dx, and bn is also changed, the limit bn is equal to 1 by pi integration minus pi to pi fx sin of nx dx. In both the cases n equal to 1 2 3 dot dot, and for particular case we will done for some special case for c is equal to minus pi and f of x even function. If f of x is an even function, then the Fourier series of f of x contain only sine term, and this will be fx is equal to summation n equal to 1 to infinity bn sin of nx dx, where bn bn is equal to 2 by pi integration 0 to pi fx into sin x dx, sin x dx. And if f of x is an even function, then the Fourier series function of f of x contain only cosine term, and this is fx is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx, where a0 is equal to 2 by pi integration 0 to pi fx dx, and an this is equal to 2 by pi integration 0 to pi f of x cos of nx dx. These are done in the first video, and the second video, this video will some particular case if c is equal to 0. If c is equal to 0, the interval c less than x less than c plus 2 pi given. If we put c is equal to 0, 0 less than x less than 2 pi, 0 to 2 pi, and now fx changes to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin of nx dx, where a0 is equal to 1 by pi integration 0 to 2 pi fx dx, and an this is equal to 1 by pi integration 0 to 2 pi fx cos of nx dx in equal to 1 2 3 dot dot, and bn is equal to 1 by pi integration 0 to 2 pi fx into sin of nx dx. For special form, here we get two special form. Special form 1, when f of x satisfying f of 2 pi f of 2 pi minus x is equal to f of x. What happened? First we know integration 0 to 2a f of x dx is equal to 2 into integration 0 to a f of x dx. If f of 2a minus x is equal to f of x, we know this, and is equal to 0 integration 0 to 2a f of x dx is equal to 0 if f of 2a minus x is equal to minus of fx. This is we know. Integration 0 to 2a fx dx is equal to 2 into 0 to a fx dx if f of 2a minus x is equal to fx, and 0 if f of 2a minus x is equal to minus of fx. This is we use f of 2 pi minus x is equal to fx. What happened? Then a0, this a0 is equal to 1 by pi integration 0 to 2 pi fx dx, as f of x f of 2 pi minus x is equal to fx. If we compare 2a, the 2 pi to here come 2 into integration 0 to pi f of x dx. And for an, let we say this is capital Fx and we compute this. For n, let capital F of x is equal to f of x cos of nx. Now f of 2 pi minus x, f of 2 pi minus x, if we put x is equal to 2 pi minus x, f of 2 pi minus x the cos of n into 2 pi minus x. As f of 2 pi minus x is equal to fx, this is equal to fx, and cos of n into 2 pi minus x, cos of 2 pi minus x cos x, or cos of nx, cos of nx. Therefore an, this is equal to integration n is equal to 1 by pi integration 0 to 2 pi f of x cos of nx dx is equal to 1 by pi integration 0 to 2 pi, this is equal to capital Fx, we put f of capital F of x dx, and as f of capital X is equal to f of 2 pi minus x is equal to f of x, this is f of x, as f of 2 pi minus x is equal to f of x, therefore 2 into 0 to pi fx dx, and these two come 2 by pi integration 0 to pi fx dx, fx dx, we put the value fx 2 by pi integration 0 to pi fx is equal to f of x cos of nx, therefore f of x cos of nx dx. And for bn, this bn, let f of x g of x is equal to this term, let capital G of x is equal to f of x into sine of nx. Then we compute g of 2 pi minus x. What happened? F of 2 pi minus x sine n into 2 pi minus x, as f of 2 pi minus x is equal to f of x, and sine of minus x, this minus come out, minus sine n x, this is n x nx, and this is our gx, the minus of g of x, g of 2 pi minus x, g of x, and if f of 2 pi minus x, this integration becomes 0, therefore bn is equal to integration 1 by pi integration 0 to 2 pi f of x into sine of nx dx is equal to 1 by pi integration 0 to 2 pi g of x, this is g of x dx, and as f of g of 2 pi minus x minus of gx, this will be 0. Therefore if f of x defined in 0 comma 2 pi be a periodic function and satisfy the condition f of 2 pi minus x is equal to f of x, then the Fourier series contain only cosine series, and this is given by f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx dx, where an is equal to 2 by pi f of x dx, and where an is equal to 2 by pi 0 to pi fx cos of nx dx, and a0, this is equal to 2 into 0 to pi fx dx. Now a special form 2, if f of 2 pi minus x is equal to minus of fx, then a0 is equal to 1 by pi integration 0 to 2 pi fx dx, and f of 2 pi minus x is equal to minus fx, and this will be 0. Therefore a0 is equal to 0, and let capital F of x same as previous, fx is fx cos of nx. Then f of 2 pi minus x, f of 2 pi minus x is equal to f of 2 pi minus x cos of n into 2 pi minus x, as f of 2 pi minus x is equal to minus of fx. We put minus of fx, and this gives cos of nx. Therefore f of x minus f of 2 pi minus x is equal to minus of fx. Therefore we get an 1 by pi integration 0 to 2 pi f of x cos of nx dx. This is equal to 1 by pi integration 0 to 2 pi, and this is capital fx, capital f of x dx, and as f of 2 pi minus x is equal to minus fx, this will give 0. Therefore an is 0, and let for bn, let gx is equal to f of x into sine nx. Then we have g of 2 pi minus x is equal to f of 2 pi minus x to sine n into 2 pi minus x, and this gives, as f of 2 pi minus x is equal to minus of fx, and here a minus come out, minus plus, sine of nx is equal to g of x, as g of 2 pi minus x is equal to g of x. What we get bn is equal to 1 by pi integration 0 to 2 pi f of x into sine of nx dx is equal to 1 by pi integration 0 to 2 pi g of x dx, and as g of 2 pi minus x is equal to g of x, these two come here, 2 by pi 0 to pi g of x dx. Put the value gx 0 to pi f of x into sine of nx dx. Therefore in 0 comma 2 pi, the periodic function of period 2 pi satisfying the condition f of 2 pi minus x is equal to minus of fx contain only sine term, and this is given by f of x is equal to n equal to 1 to infinity bn sine of nx, where bn is equal to integration 0 to pi bn, this bn 2 by pi, or 2 by pi come 2 by pi into integration f of x sine of nx dx. Summarizing all this, result 1, Fourier series of f of x in the interval minus pi less than x less than pi is given by f of x, this is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin nx, where a0 is equal to 1 by pi integration 0 to pi fx dx. An, this is equal to 1 by pi integration 0 to pi f of x cos of nx dx, and b of n, this is equal to 1 by pi integration 0 to pi f of x sin of nx dx. Both the case n equal to 1, 2, 3 dot dot. Result 2, Fourier series of an odd function in the interval minus pi less than x less than pi is, what is this? F of x is equal to summation n equal to 1 to infinity bn sin nx dx, where bn is given by 2 by pi integration 0 to pi fx sin of nx dx n equal to 1, 2, 3, 4 dot dot. Result 3, Fourier series of an even function. Fourier series of an even function in the interval minus pi less than x less than pi. This is given by f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx dx, dx হবে, where a0 is equal to 2 by pi integration 0 to pi fx dx, and an, this is equal to 2 by pi integration 0 to pi fx cos of nx dx n equal to 1, 2, 3 dot dot. Result 4, Fourier series of f of x of a function in 0, 2 pi is given by Fourier series fx in 0, 2 pi. The function f of x is given by f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin of nx, where a0, this is equal to 1 by pi integration 0 to 2 pi f of x dx, an is equal to 1 by pi integration 0 to 2 pi cos of nx fx into cos of nx dx. Result 5. If f of 2 pi minus x is equal to f of x, then the Fourier series of f of x in the interval 0, 2 pi is f of x is equal to a0 by 2 plus only cos cosine term content n equal to 1 to infinity an cos of nx, and where a0 is equal to 2 by pi integration 0 to pi fx dx, and an, this an is equal to 2 by pi integration 0 to pi f of x cos of nx dx n equal to 1 to dot dot. Result 6. If f of 2 pi minus x is equal to minus of f of x, the Fourier series of f of x in the interval 0, 2 pi is, today we done this fx this is equal to n equal to 1 to infinity bn sine of nx, f of 2 pi minus x equal minus of f of x, only sine term content, where bn this is equal to 2 by pi integration 0 to pi fx sine of nx, fx into sine of nx dx, and n belongs to natural number, n equal to 1 2 3 dot dot. This is all for today.